Hello, good evening. Welcome to the Corning Museum of Glass. For those of you here in the amphitheater, warm welcome to you and welcome to our guests online viewing the live stream. Tonight we're going to be talking a little bit about an exhibition coming up here, or that is happening right here at the Corning Museum of Glass called Dig Deeper, where we explore an ancient glassmaking site in Jalame. Tonight you're going to see some of the techniques that would have been used in a glass factory like that, along with some contemporary modes of some of the design that you see in pieces from that site. So Chris Rochelle is going to be our gaffer. He's going to make something for us this evening. He's going to be assisted by Katie Hubbs. My name's Jeff Mack. I'm going to be telling you about the process. And we were hoping to have Kate Larson here, who is the curator of Dig Deeper, who put the show together. But unfortunately, she couldn't be here with us tonight. Fortunately, Kate was kind enough to create an introduction video for us. So we're going to go ahead and run that video. If you don't mind, Jason, why don't you send that on the screens? Thank you.
Hi, I'm Katherine Larson, curator of ancient glass here at the Corning Museum of Glass. I'm also an archaeologist and the curator of the special exhibition, Dig Deeper, Discovering an Ancient Glass Workshop. Dig Deeper is an exhibition about the way archaeologists work with scientists and glass artists to understand ancient glass. I hope you'll have the chance to see it during your visit. As I was working on the exhibition, I really wanted to share that process of discovery with our hot glass team and with you, our visitors. So I asked the hot glass team to build a wood-fired furnace similar to the ones that would have been used in the ancient world. And they said yes. Fortunately, we didn't have to start entirely from scratch, and we were able to talk to colleagues and friends who had built similar furnaces and learn from their successes and failures. We discovered that our greatest challenges, things like making the daub material, a mix of straw and refired ceramic to build the furnace, that was hard for us because we'd never done it before. But it would have been really simple in the ancient world since it was such a common building material. No one was more surprised than us when the furnace worked beautifully, as it was designed. We were able to melt and blow glass after just a few hours of bringing up the temperature. Even an untrained person like me was able to keep the furnace stoked to temperatures above 2,000 degrees Fahrenheit. Our gaffers will often say that glassblowing process is largely unchanged from 2,000 years ago, when glassblowing first started in the ancient Roman world. And that's true. But the wood-fired furnace project helped us all realize that what happens at the end of the blowpipe is only a small part of the story.
All right, thank you, Kate, for that nice introduction. The video we're seeing right now is our team working out of the wood-fire furnace that Kate was just talking about. As this continues to roll, our gaffer, Chris, is going to begin the piece he's making for us today. As he works, you're going to notice similarities between the two, but you'll also be able to pick out some of the big differences between how we work in a modern hot shop in comparison to the ancient workshop and furnace design. One thing to notice right away is that there's no bench at the wood fire setup. Ancient glassmakers used smaller blowpipes and rolled them on their lap with a fixed strap on the right leg, or else they would roll the pipe on the rim of a large ceramic bowl. They also likely remained seated for most of the process, able to gather the glass and reheat it all from the same port of the furnace. Nowadays, we make use of a separate reheating furnace, allowing us to work on much larger scale. Since the opening we gathered from in the wood-fire furnace doubled as the reheating port, we were limited to making small-scale items. You may also notice in the video someone loading wood into the furnace, stoking it every so often to maintain operating temperature. Without them, the glassmaker wouldn't be able to resoften the piece or even gather the glass on the end of the blowpipe. The furnace must hold temperatures close to 2,000 degrees Fahrenheit for most of the process. And most modern hot shops use burners powered with natural gas or propane and are equipped with electronic thermostats and controls to maintain the ideal temperature all the time. So here we are. We'll come back to those comparisons soon, but let's check back with Chris. Again, Chris is going to be assisted by Katie. My name's Jeff. If you have any questions here in the audience or online, feel free to let us know, and I'll be happy to answer them as best as I can. While we were watching the video, Chris started the core bubble. He's going to go in for his second gather now. So while he's working on that second gather, he's going to use a wooden tool called a block here. I'm going to talk a little bit about our exhibition that is on view right now in the museum, running through January 7th, and it's called Dig Deeper, Discovering an Ancient Glass Workshop. Dig Deeper is an immersive and fun exploration of the world of ancient glass makers and those who study them. In the 1960s, archaeologists from the Corning Museum of Glass and the University of Missouri at Columbia excavated a glass workshop in Jalomeh near Haifa in modern-day Israel. This factory was active between 350 and 400 CE. Among the discoveries from Jalomeh, which will be on view in the exhibition, are chunks of raw glass, parts of the glass furnace, debris from glass blowing, and fragments of utilitarian glass vessels. The exhibition also includes opportunities for visitors to touch ancient glass and hear sounds of a working excavation site at and a wood-fueled furnace. Further on, there's hands-on activities, including an archaeology lab, which brings the process of archaeological exploration to life for all ages. So it's a really family-friendly exhibition and a great one to share with children, for sure. Special highlight will be a digital game experience, which visitors can join in the Jalomeh excavation team and make their own discoveries. So make sure to check that out on your next visit to the museum. So where are we at now? Okay, Chris is forming kind of an atypical or a typical round bubble here. The thing you're going to notice about this next few moves is that Chris is going to cut that bubble in half, and he's going to form a foot out of the bubble. He's going to make a fold in the bubble. And this is a technique that you see lots and lots in ancient glass from the 1st through the 5th and the first 1,000 years of glassmaking. So at the Jalomeh site, there were a lot of fragments found, not full pieces, but pieces of full pieces that had folds in them, including around the foot. And I can show you some images that kind of show you some of these things. This image here, I'm going to see if I can pull something up on the, maybe not.
Hi, I'm Katherine Larson,
Whoops.
curator of ancient glass here at the Corning Museum of Glass. I'm also an archaeologist and the curator of the special exhibition.
That wasn't the right button. So anyhow, I'm not going to share that image with you right now, maybe later. But Chris is going to heat the bottom portion of that bubble. He'll stretch it a little bit, and then he'll go in with his jacks to cut a constriction, dividing that bubble in two. And then the bottom portion of that bubble is going to be smushed into a flat disc. So one of the cool things that's highlighted in the Dig Deeper exhibition is the relationship between the archaeologist and people in different trades, scientists and artists. And these people help the archaeologists to kind of paint the picture of what a workshop like that may have looked like, 1,500 years ago, because we don't have video of it. We don't have pictures. All we have are the shards and the trash that was left behind. So we look at these little pieces and we can learn and discover. An archaeologist on their own might not know what these shards mean, but when they come to a glass maker or an artist who works with glass every day, we can say, wow, that looks like that bubble was folded using the jacks. So we can show the archaeologist, we showed Kate, this is how we would do that, and it's probably very similar to how the ancient people would do it. Here in our modern shop, we have a workbench here with rails that we roll things back and forth on. The ancient workshop didn't have these. There's no evidence of this at the site. So a lot of people who have studied this and have, tried to recreate some of these processes have discovered that it was likely that, we were the glassmakers were rolling the blowpipes back and forth on their laps, and they would put a strap of some kind on their one leg so that the heat from the blowpipe, didn't burn up your leg or catch your pants on fire. All right, so there's the foot. The foot's completed on this piece. Now, the piece that Chris is making right now is very similar to what you would see from Jalome, only it's scaled up. So this would be like a drinking cup, but Chris is making it into something that's the size of a fruit bowl. So he's kind of scaling it up so we can see things a little more in detail. And, the folds in the bubble are a cool feature from the ancient glassblowers that they would use to decorate and create different forms. Another thing they would do was add handles. So if you look at pottery from the same time period or silver, they have a lot of the same elements. So the glassmakers were kind of imitating other materials that were used for making vessels at the time. So Chris is going to add some handles to this cup or bowl, but he's going to do it as they would have in ancient times, without using shears. So normally nowadays, if we add handles, we have special shears we can cut the glass off with. But back then, they would use the heat of the glass to cast that glass off. So they would use the heat to kind of peel it away and thin it out into a small stringer. So you're going to see Chris doing that with this piece. He's going to add a couple of handles after he opens it up and puts some bits on there. And you'll see how he does this. And this technique goes back 2,000 years. Now, after Chris finishes this piece, he's going to do another piece of his own design, but it's influenced and inspired by the ancient technique. So he's going to use folds to create basically a decorative piece. And here's a good example of a piece that Chris did using the same type of techniques that the ancient glassblowers were using at Jalome. So this is a big fold in the bubble that he's created the foot with. And this lip also has a fold in it. So the bubble is turned back on itself and touched back down. And this is something that you folks here on site are welcome to come and look at if you get a chance. I'll just set it right here. So a lot of the glass that you'll see in the Dig Deeper exhibition is green. And a lot of ancient blown glass had a green cast to it, because one of the most common impurities you find in sand and silica is iron. And iron will cause the glass to turn green. So at the time, in 400, they didn't really know the chemistry of the glass as well as we do today. And so they would, find sand from a certain area and know that that would give them a certain color. And this light green was about as clear as you could get back in those days. And it wasn't until the 16th century that true clear glass was invented by the Venetians. And they called that cristallo because it imitated rock crystal. So Chris is stretching the bubble with tweezers. Here he's using some scissors, a modern tool. You wouldn't see this in the ancient workshop, but it's a nice way to clean up the edge these days. He has to work very, very quickly to get a nice clean trim on that lip. If he takes his time too much, the glass is going to be too cold by the time he makes his way around with the scissors, and he might start cracking it. So you have to work very quickly. Are you going to fold this rim at all, or you're putting a... Okay, so Chris is going to put a little detail in here. He's going to work with Katie to put a wrap around this near the rim of this. And that's going to do a couple things. It's going to add a neat little design element, but it also gives him sort of a line that he can use to gauge where the handles go when that part comes, which will be coming very soon after this bit is added. So Katie's gone over to our melter. She gathered up a little ball of glass. Chris is going to use his shears to cut that to a point, almost like sharpening a pencil. and then he can just touch it on and draw it back, and it stretches into a fine thread. A steady hand keeps it flowing in a straight line. And Chris makes that look so easy. Perfect line. That's pretty cool. Every time I do that, it looks like a squig. It looks like that pattern on Charlie Brown's sweater, you know, where it's kind of going up and down. So back to the furnace, he's going to melt that in and start to expand the lip of the bowl. This is a great time to take any questions if anybody has any. Do you have a question online? Two questions, yeah.
What is the age of the blocks relative to glassblowing, and what were ancient blowpipes made out of?
So, two questions. What is the age of blocks relative to glassblowing? That's a great question, and I actually don't have an answer to that. I don't know. It's likely that the Romans and ancient glassblowers, early glassblowers, were probably using wooden tools because that's a material they would have had very readily available. However, I'm not sure if they were using blocks. They were probably rolling the glass on marble or on stone to shape it. That's where this tool comes from that's in the center of our shop. This is our marver. We call it a marver. That's an old French word that means marble. These slabs used to be made of marble. So that was an early shaping tool. We would roll it on there. Now, the other question was, what were the blowpipes made out of? So they found scrap glass that has come off of blowpipes at the Jalame site. Those are called moils. So the glass that is left on the blowpipe eventually will pop off the blowpipe. Usually it breaks in half or in thirds. And we have piles of them here every day. You know, after making 20 pieces in a day or so, we have 20 moils, or, you know, the glass that's left over on the tip that has blown apart or broken apart. So we have those scraps too, but they have those from Jalame. And on the inside of them, there's iron. There's scale from iron pipes. So they were using blowpipes that were made of iron. Now today we use a form of iron. Well, we use stainless steel, which has iron in it, but it's just a lot cleaner and doesn't really transfer the heat as quickly as iron would. So we use modern materials, but pretty similar. So ancient glass makers were using iron blowpipes. And we know that because of the shards from Jalame, from the Jalame site. Great questions. Does anybody else have questions about the ancient glass or about what we're doing here? All right, so they just put one of the handles on. I totally missed that. But you notice that Chris did not use shears. And this is exactly how an ancient glassmaker would have applied the handles. We know that because the handle fragments that we see from places like Jalame and from ancient Roman sites have little stringers attached to them. And you can watch as Chris applies this where those stringers come from. So he pulls out a little detail there, stretches the glass, touches it to the rim, and then he pulls it out, and the heat and the force is enough to just break that little stringer. He can incorporate that back into the handle. That little whisker there, he can just pluck off, and it'll melt away and leave just a little indication of a string on the top of that handle. And when you look closely at ancient pieces with handles, from the first through, you know, the first maybe 500 years of glassblowing, you see that little stringer on the top of handles. So that's how we know that's how that was done. And we don't see shear marks because the marks that we make with shears when we clip the glass leaves a distinctive mark. So these are the clues that glass makers can look for to help archaeologists identify how something was done. So Chris has put the second handle on, and it looks like a mirror image of the first handle he put on there. What do you guys think of that? That's a beautiful piece inspired by ancient blown glass. In 400, this would have been considered a giant drinking cup. Beautiful piece. So many of you who are watching today probably know this, but when we finish a piece of glass, we have to cool it very slowly. So if we just took that off of this iron, which they're about ready to do now, and how does Chris do it? A little drop of water causes a little thermal shock where it's attached to the iron. A sharp tap will cause a shock wave that breaks it free. And Katie is going to carry that over to an oven that is 960 degrees Fahrenheit. I'm going to open the door here for Katie. Everything we make today goes in this oven. It'll sit there until the end of the day, and when we're finished producing for the day, we shut that oven off. A computer controls the rate at which it cools, and it cools at about 100 degrees an hour. So tomorrow morning, that piece will come out in one piece. If we just let it sit out in the open air, the glass would cool so rapidly that it would cause thermal shock. Some of the parts of the glass would still be expanding because they're very hot. Some are contracting, and that stress is going to cause it to break. So thermal shock happens, and I'm sure we've all experienced it in one way or another, even if it's dropping an ice cube into a glass of water and watching it pop apart. That's thermal shock. So when a material changes temperature and it's shocked by that rapid change. So a lot of people wonder, well, you have a computer-controlled oven to put your glass into. What was the ancient glassmaker going to do? How would they cool their glass down? Well, the most basic way in a small furnace is they would pack the glass into a chamber that was above the firing chamber. So it would have residual heat from a flue of some type or next to the heating chamber. And after they were done working for the day and used up all the glass, the entire furnace would be shut down and cooled down just naturally. The thermal mass from that furnace radiating into that secondary chamber was enough to keep the glass warm enough for a long enough time that it wouldn't break. So that was how annealing started. Also, there's evidence that, and I'm not sure it was at this site, but at other ancient sites, they found different type ways of cooling the glass. So separate furnaces that were made just for cooling the glass down. They also found pits that were filled with olive pits, and they would sometimes, it's thought that they would bury some of the glass in olive pits, and that insulation kept the pieces whole and kept them cooling down at a slow enough rate that they wouldn't break. Another form or another technology for cooling the glass that came along a little later is a leer, which is a tunnel that would be coming off of the furnace. There would be a flue that vented into this tunnel. So the closer it was to the furnace, the hotter it would be. And they would have little trays connected by chains that they would set the glass on, and somebody would be there pulling those chains and causing those trays to kind of slide away from the furnace a little bit at a time. And by the time it was down at the end of the 20-foot, or I don't know, how many feet tunnel, you would have a finished piece of glass. And actually that technology is still used today in industry. It's called a leer. And the glass actually passes through zones of temperature. So our ovens, the piece of glass stays in one place, the whole oven goes down to room temperature together. But in a factory where you're producing things all the time, it's very handy to have an oven that you load it in one side hot and it comes out the other side cold. And that can run continuously 24/7. So here we are. Chris is now going to make his contemporary take on the techniques that we've looked at from Jalame, from the ancient glass-blowing world. And he's going to use some of those cool folding techniques to design a neat little bowl. And I showed you one here before that he made yesterday, I think. And I saw him making another one today. But this is just kind of using these ancient techniques in a contemporary mode. And that's a lot of what happens in glass, in artistic glass. And you can see it in our 35 Centuries of Glass gallery. Most all of the techniques for decorating and forming the glass at the furnace on a blowpipe were developed in the 1st century. And since then, it's been kind of iterations of those basic techniques over and over and over, reinterpreted. And that's what Chris is going to do right now. And I think it's really fascinating that the same type of techniques that were exciting to glass blowers 2,000 years ago are exciting to us today as glass makers, and we can do cool things too and show off our skills by making the same type of folds that a glass maker was making back then. So it's kind of a fun connection to the past and people who did the same type of work, thousands of years ago. It's kind of fun and interesting. All right, so this is how we're going to add color to the glass. The last piece was all clear glass. Chris is going to do what's called an overlay right now. So Katie has what is the color you're using, Chris? Okay, so this is an amber color. Everything looks orange when it's hot, so this is going to look like orange glass, but it's amber. And Chris is going to take that amber glass, that little bit of amber glass, he clips it onto the bubble he's formed, and we call it an overlay because he lays it over that bubble and creates a little veneer of colored glass over top the clear glass. Then he'll gather another layer or two of clear glass over top of that, and when he blows that out, that thin layer expands with that inner bubble. So the entire bubble will look like it's made with this amber colored glass. Now, a lot of people wonder how we get the colors in glass. And I told you earlier, ancient glass, a lot of it was green because iron is very prominent, what do you call it? Yeah, it's a metal that shows up in the sand a lot. A contaminant, we would call it, unless we're purposely coloring our glass green. So when we start to get our clear glass, all the metals have to be removed. All the contaminants have to be removed. So the sand is milled and it's refined, and there's processes to getting all of the metals out of the glass out of the sand as much as possible, so we get a very pure, clean, clear glass. Now, if we want to intentionally add color, we would add metals back in. So some examples of metals that, other than iron, that give us color. Cobalt makes blue, right? We've all heard of cobalt blue glass. Cobalt describes the metal that makes the color. Manganese makes purple glass. Reds and oranges are cadmium and selenium. Tin will make white glass. So metals are added into the glass to give it color. But the main ingredient for most glass is sand. We call that the former. Other constituents are flux, which lowers the melting temperature of the sand, makes it much more workable. If we didn't have a flux in our glass, we'd have to get it to 3,000, 4,000 degrees. We'd have a white hot furnace that we would not be able to look into with our naked eyes. We'd have to look through a shield. We have a shield there that we look through, but we don't need it all the time. But if we had a white hot furnace and we couldn't see into it, we'd have to wear a big hood. It would be hard to work with. So the flux that's added into our glass is soda ash. That makes about 20% of the mixture. The sand is about 70%, silica sand. And then the final ingredient is a stabilizer. The stabilizer keeps the glass from breaking down over time, and that is calcium carbonate. So sand, soda ash, or sodium carbonate, and limestone, or calcium carbonate. And those three ingredients are the basis for all the glass that we use here, and for about 95% of all the glass you see around you. All right, so Chris has his core bubble. He's going to cool that down a little bit here. He's using compressed air to do that. We want that bubble to be cool so that it's stiff enough to hold the heat and the weight of another gather. He could make a small piece with this, and many of the pieces from the Jalame site were very small, like a little juice glass size. That was kind of primarily what you'd see made out of an ancient furnace. Though they did have the technology, and they made furnaces big enough to accommodate very large pieces. And you can see some very large pieces of blown glass from the 1st and 2nd century of glass blowing. So they developed the technology very quickly once it was invented. So Chris is going back into the furnace. He dips in there, turns in one direction. He'll come out with a nice even coating of molten glass. He meters off some of the glass so he has just the right amount for the piece he wants to make. And there's the mysterious block that we don't know when it was invented. That is a great question. I'm going to have to research that a little bit. Thank goodness I work at the Corning Museum of Glass, where I can do that very easily. So here's a cool tool. Many people talk about that tool being first used in Murano by a glass blower named Alfredo Barbini. It's newspaper, folded up newspaper, soaked in water, and it's a great tool for shaping the glass because you can constantly change the contour of your hand, therefore change the contour of the glass as you're shaping it. So it's a nice tool to have as direct contact with the material as possible. And that's kind of nice for us because we can't actually use our hands on the glass, as you might have guessed. Did this get another dip, Chris? All right, so once again, letting the glass cool down just a little bit before the final gather. So we're sad that Kate couldn't be with us this evening, but Kate has promised to come and be with us during our next live streams that have to do with the same subject. We're going to do a couple live streams with our wood fire furnace outdoors in our courtyard stage. We have a live stream on the 6th, on July 6th and July 20th. And you'll get to see us blowing glass with the wood fire furnace online if you would like to. You can also come here to see live glass making out on the courtyard stage on Thursday evenings at the wood fire furnace. Starting, let's see, when does that start? That starts in July too. So every Thursday in July, we're going to be firing that wood fire furnace, and in August. And that's going to run from 3 to 6 p.m. outside on the courtyard stage. So make sure to come back, and then if you can't join us live, make sure to check out those live streams. Kate's going to join us for those. Again, that's the 6th and the 8th of, or the 6th and the 20th of July. Live stream runs from 5:30 to 6:30. So be sure to check that out. The wood fire furnace is so much different than watching a demonstration here in the amphitheater. And if you're into watching glass blowing, I definitely would check that out. It's such a neat experience to see that and to realize that. And there's been so many questions about that over the years. So to be able to actually demonstrate that it is possible and show people, yeah, you can melt glass with wood and you can achieve temperatures like this over 2,000 degrees with wood, and it's not that hard. It just takes a lot of wood. But not as much as I imagined, actually. All right. Does anybody have any questions? Yeah. So the wood fire furnace. Yeah. The wood burning furnace, the wood fire furnace that we built does not have an annealing chamber. So we're actually annealing. We're cheating. We're annealing stuff. We were going to build a chamber, but it wasn't tested. And because we're running a program with it, we built a furnace that we knew would work. So actually, the furnace that we built first was made of daub. So it was actually the traditional material that they would have used 2,000 years ago to make a furnace like they had at Jalame. So it's reclaimed clay and straw and hay mixed together. And it insulates better than you would imagine. However, it is very brittle, and the more you fire it up and cool it off, the more brittle it becomes. It starts to fall apart. We fired that furnace over a period of a week, and it was kind of falling apart. We did that for the filming for the Dig Deeper show and the footage that you see in that exhibition of people working at the wood fire furnace. That's us working at our first iteration. Then for this summer program, because we're going to have to fire it a dozen times, we made it out of modern materials. So we used a castable refractory, a high temperature castable refractory. We used ceramic fiber insulation, and then a coating of plaster and sand to make a kind of a hard shell. So we use modern materials that are going to take that up and down shock much better than the daub furnace. So we built that so we were guaranteed to have a furnace for the programs that we're advertising for. If we do it again, though, we might build a chamber off of it that is actually annealing the glass as it would have been 2,000 years ago. But that's a great question. All right. So Chris is preparing to make the folded foot on this piece. It's going to be quite a bit different than the one you saw on the more traditional piece. It's a heavier fold, it's a bigger fold, and it creates kind of a pedestal that the piece sits on. So it's done a little bit differently, and you can see he's using the torch to aid in the formation of that, to kind of spot heat a zone that he wants to change the shape of. I saw some other hands up for questions. Yes? Yeah. So this tool called the jacks, we heat them up. The glass heats them up too. But then we rub them in wax because they need to be lubricated. If we didn't lubricate that with wax, when we dragged it, when it slid on the surface of the glass, it would create scratches and lines that wouldn't melt out, or gouges. So that wax is like a lubrication to keep it kind of gliding on the surface of the glass. When it runs out of wax, you'll know because you'll hear it squeaking. It sounds like fingernails on the chalkboard kind of thing. So you just want to get that wax on there real quick. So Katie's doing that because she knows that Chris is about ready to do some serious moves using the jacks. So she wants to keep them nicely lubricated. Great questions, guys. Anybody else? Yes, sir. How long does he have to do what he needs to do before he needs to reheat again? So when he first gathers the glass right out of the furnace, he's got a couple minutes because you have that intense heat right out of the furnace. It's 2,100 degrees, and you try and get as much done in that 2 minutes as you can. Then after that, once you blow the glass out, it becomes thinner, and the thinner the glass is, the more quickly it dissipates its heat. It has more surface area exposed, and it lets off its heat a lot faster. So right now, maybe he's got like 30 seconds or so to work with the glass before he needs a reheat. Once it gets on the punty, once it's flipped around, maybe 20 seconds. So he's got to work very quickly. He has to plan his moves. And a lot of times what a glass blower is doing is they're working at the furnace. When they're heating at the furnace, they're thinking about what they're going to do when they sit down. And they have it planned out in their head. So Chris is thinking about his reheat now. When he's up there, he's going to think about the next moves he's going to make. So it takes some planning, for sure, for sure. These are great questions, you guys. Great questions. I love that question. Any other questions online? Oh, dichroic glass.
Yeah.
Okay. Can you add a cold say again?
Cold work dichroic element to a hot work, like a glass blowing cup.
You can, yes. So you can take cold work dichroic glass and add it to hot molten glass. A little bit off the topic of ancient glass, but yes, you can do that as long as the glasses are compatible. And what does that mean? Not every glass fits with every other glass. So let's say Chris wants to make this bowl in bright orange. The bright orange color that he overlays might not have the same characteristics as the clear glass he's putting it on. And one characteristic that glass has that's very important to glass makers is called the coefficient of expansion. And that basically talks about how the glass moves as it cools down and as it heats up and how much it does. And if your coefficient of expansion of one glass is way off from the coefficient of expansion of another glass and you try to put them together, they will break. They have to be in a sort of within a couple of points of each other to be considered compatible. Now you can get away with certain things depending on how you work with it or how thin you make the glass, or if one glass is more dominant or thicker than another glass, you can kind of get away with putting glasses that technically would be incompatible together, but that doesn't always happen that way. Great question. Dichroic glass, yes you can. Maybe, if it's compatible. All right, so Chris has blown a round bubble. He wants it to be flattened out because he's making a lower bowl. So we're going to make a low bowl with this. So he's flattening that bubble out to just start that low shape. So Chris has the ring in there, and you can see the difference between this type of foot and the one he made before. The last foot that was made out of the fold of the bubble was kind of flared outward like a bell, the bottom of a bell. And this one is vertical. And you definitely do see platters, oval platters too, from from ancient times that had a foot like this. Not necessarily that big though. So Chris is really riffing from ancient forms and creating sort of his own contemporary take on this ancient technique, which is a lot of fun. It's a lot of fun for a glass blower, again, because it gives you that connection to craftspeople who were working with this material so long ago. And it's a shared experience that you have with people who existed before you. And to me, that's a lot of fun. And I know to my colleagues here who love museums and work at museums and look at a lot of things that people who lived a long time ago made, it's nice to feel that special connection. All right, so the bottom portion of the bowl is complete. The next thing to do is flip it around and work on the top. So Katie's prepared the puntee. The puntee is our finishing handle. We're going to stick it right to the center of the bottom. Chris will break it free from the blowpipe, leaving the little hole that he was blowing into to inflate the glass, which will become the rim of the bowl. And he will take that rim, he's going to flip it over on itself and double it up to create one more little fold. So one more little special effect for the bowl. Chris made a really cool sample of a folded bowl a few weeks ago, and he sawed it in half. And you could see the contour of the folds in it. It's really, really neat looking. All right, so once that's centered and stiffened up a little bit, Chris will break it off the blowpipe. And it's just the same as breaking it off the puntee. A cold tool or a drop of water is enough to shock that glass into breaking. And that sharp tap releases it, completes the crack. And back to the furnace they go. If you've not seen glass blowing before, you may not know this, but the entire time that Chris is working on this piece, he has to keep it over 1,000 degrees. If it drops below 1,000 degrees, that's the danger zone. It's very likely that the glass is going to break if it's there for any amount of time. Sometimes it gets cold. When we go back to the furnace, the heat from the furnace shocks that glass, it breaks. Sometimes it pops apart in the furnace. That's a real bummer. Sometimes it falls off the puntee. It doesn't happen too often, and I'm betting it's not going to happen tonight, but we'll keep our fingers crossed. So he's going to heat that front slope there on the bubble. And that's going to take a little bit. In the meantime, I do want to talk a little bit more about our program with the wood fire furnace outdoors and things that are going to happen with that. So along with the wood fire furnace, we are going to have brewery tastings with Scale House at the same time. So it's kind of something for the whole family, you know. You can go on and try some samples from the Scale House and, you know, watch a demo with the kids. It is family friendly. There is something for everybody. And again, our wood fire furnace demos start at 3 p.m. and run to 6 p.m. So there's a little overlap there. A great event to come out to. And that's every Thursday through July and August, each afternoon into the evening. So make sure to come out and see that. It's a lot of fun to, you know, see glass melted in this way. It's kind of a special thing. And then again, a reminder that the curator of Dig Deeper will be joining us for demos out on the courtyard stage at our wood fire furnace. That will be live streamed once again. So if you're not able to make it in person, you can check back and check out the wood fire furnace online. And that's July 6th and July 20th from 5:30 to 6:30 p.m. So we hope you can join us then too. All right, so Chris used an oxypropane torch to spot heat the very, very tip of that rim. He's going to go back in there here in just a moment and fold that over on itself. And with this design, it adds a cool element, linear element around that lip, but it also adds a little durability, so it's functional as well as fashionable. So there it is. Folding. So what happens when he folds that is the very rim will touch back and fuse onto the shoulder, but inside of there's air trapped. So he has basically a bubble like a donut that goes all the way around inside of that. And it's really, really tricky to keep it from touching back in one spot or sealing and just keeping that bubble kind of open like a tube all the way around. But Chris is incredibly skilled, and he's very good at doing this. Now, when we open a wide bowl like this, we use jacks, but we use jacks that have softer blades, wooden blades. These are called parchofis. The metal-bladed tool, even if you put a bunch of wax on there, you still might get scratches. So we use parchofis to open a bowl like that. That's a pretty cool shape there. Are you going to flare it out more, or are you going to? Okay. You're going to leave it round like that? Very cool. Very cool. Here's an example of one he made yesterday that has kind of more of a platter look. It's flared out. So really cool contemporary design, but again, using ancient techniques as the source for inspiration. So this is the kind of stuff I really, really enjoy. And I hope you do too. And I hope you'll join us again as we explore more ancient techniques at our wood fire furnace and here every day, actually, starting June 26th, we're going to have a demonstration about dig deeper and utilizing some of these techniques to make some cool pieces like this one you see Chris making right here. What do you guys think of this beautiful bowl? Pretty amazing. All right. So Chris is just going to balance the temperature out. You feed some heat back into the punty there. And again, the final step is the slow cooling. He'll break it free from the iron. Katie will carry it over to our oven where it'll cool down over about 10 or 12 hours. Tomorrow we'll pull that out. And look at how pretty it is. All right. Here we go. All right, there we go. Beautiful job. So the slow cooling process and this oven, and what this oven does is called annealing. It's an annealing oven. And we'll check that out tomorrow. Let's hear it one more time for Chris Rochelle, Katie Hubbs, and that beautiful piece. Make sure to get down here to the museum and check out Dig Deeper. Come on back when we're firing the wood fire furnace on Thursday evenings from 3 to 6 p.m. get a load of the brewery tasting, and then come on back or check out our live streams that are going to be happening on July 6th and July 20th from 5:30 to 6:30. All right, thanks for being here.